So we're going to graph parabolas in what I consider to be the most efficient way, just like graphing lines. We plot 2 points, we draw the line through, and we plot specifically the x and y intercept. We're going to do a similar thing for parabolas. So when you're graphing a parabola, there's kind of 4 things to take into account. 3 or 4 things. We want to find the vertex. The vertex is kind of the #1 most important point of the parabola. It's the highest point on the parabola if it opens downwards. It's the lowest point on the parabola if it opens upwards. But it's always one of the extremes, either the highest or lowest, depending on which way it opens. And I typically like to label it using the coordinate v sub x, v sub y. So typically when I'm finding the x coordinate and the y coordinate of the vertex, I will call it vx or vy, depending on which I'm finding. And then we're going to find the y-intercept. A parabola will always have a y-intercept. And then we're going to find the x-intercepts if there are any. Sometimes you might only have 1. Sometimes you might have none. Sometimes, a lot of the time you'll have 2. So that's kind of it. That's the whole process. And we'll talk about how to find all the things. So let's look at kind of the #1 example of a parabola, what I like to call everyone's favorite parabola, which is, let me brighten this up a little bit. Y equal to x squared. That is everyone's favorite parabola. It's the one that's the easiest to draw. And all the things are kind of the same, meaning literally the vertex is the point 0, 0. The y-intercept is the point 0, 0. And the x-intercepts, there's only one of them, and it's the point 0, 0. All the things are the origin here. And it's pretty easy to graph. Oops. I'm running out of pens. I need a. Whoops, that's not my best job graphing it ever, but you get the idea. That's what it looks like. You could plot points. I don't think you really need the plot points, but we would have the point, for example, like 1, 1 and 2, 4 and -1, 1 and -2, 4. But honestly, when I'm graphing a parabola, why is it the origin? Oh, that's a good question. Why is it the origin? Well, so if we plug in 0 for x, we get 0 for y. And taking into account that so there's a way of finding the vertex. Technically, if you've got y equal to ax squared plus bx plus c, as long as a isn't 0, which it can't be, because if a was 0, you wouldn't have a quadratic and you wouldn't have a parabola. So as long as a is not 0, the x coordinate of the vertex is -b over 2a. And in this case, since there is no b, the b value would be 0. So in this particular example, you get -0 over 2 times 1, which is just 0. So the x coordinate is 0, and then we can find the y coordinate. If you plug in 0 here, 0 squared is 0. For this one, you can also see it because it is the lowest point on the graph, right? If you're graphing y equal to x squared, all of the y values have to be non-negative, right? If you're squaring something, you always get a positive number out, or you get 0 out when you square 0. So 0 squared gives you the lowest y value possible, and the lowest or highest if it opens downward. But the extreme value is where the vertex is located. So this is what we call, this is the parent graph of all other parabolic graphs. Yeah. So we're going to talk about it. So to find the points on the parabola, so that's not exactly right. We're going to talk about how we find the vertex, the y-intercept, and the x-intercepts. But so I would say to find the intercepts, you're totally right, Faith. Yeah, exactly. So this one is y equals x squared plus 0x plus 0. That's which is someone just wrote me. I'm not writing those things, but you're totally right. We could certainly write this as y equals 1 times x squared plus 0 times x plus 0. And then that's how we can see that, oh yeah, the vertex is -0 over 2 times 1. And to respond to Faith, yes, to find the points of the parabola, to find the intercepts, you would certainly put in 0 for x to find the y-intercept and 0 for y to find the x-intercept or intercepts. But the vertex, which we want to talk about, is the most important point. So let's talk about that. And yeah, we got lots of examples here. So let's graph the following. Let's graph y equal to x squared minus 6x minus 7. A couple of things I'll say before we graph this. I don't want you to plot a bunch of points. Yeah, you could. You could plot tons of points and get a pretty good idea what the graph looks like. But here's the thing. When it's a quadratic graph like this, we know it's going to have a parabolic shape, right? If you have something of the form y equals ax squared plus bx plus c, always has a parabolic shape. As long as a doesn't equal 0. Okay. Also, sometimes it's going to be more convenient to think of this as a function. So we could also think of it as f of x equal to x squared minus 6x minus 7. To graph this, we're going to find the 3 things I just talked about. So let's find the vertex first. I need to, I'm bending over a little too much. I should raise this up a little bit higher so I can not be hunched over as I write things. Yeah, that's a good idea. Use the things you got. All right, so to find the x coordinate of the vertex, it's just going to be negative b divided by 2a. In this particular problem, our a value is 1, our b value is negative 6, and our c value is negative 7. So to find negative b divided by 2a, it's just going to be negative 6 divided by 2 times 1, which is 3. So that's half of the vertex, right? It's the x coordinate of the vertex. We still have to find the y coordinate. So I'm getting shorter as we go on, because I'm keep raising this up. Oh, I think that's okay. To find the y coordinate, we're just going to plug in the x value to the parabola. So I'm going to find f of 3 so that I can find the y coordinate of the vertex. That's going to be 3 squared minus 6 times 3 minus 7. All right, all I'm doing is I'm just substituting in 3 for x. And that's going to equal 9 minus 18 minus 7, which is negative 9 minus 7, which is negative 16. So my vertex coordinate pair is 3, negative 16. Great, we've got the vertex. The other nice thing about writing the parabola this way is the y-intercept is really, really easy to see. If I want to find the y-intercept, all I have to do is substitute in 0 for x. So that's going to be f of 0, and that's going to be 0 squared minus 6 times 0 minus 7, or negative 7. So the y-intercept is 0, negative 7. That's an excellent question, Karen. I'll address that in a moment. So I feel like I'm like cutting my face off here. That's an excellent question. You should be happy to have your name associated with it. Someone asked, where does the negative b over 2a come from? And I'll definitely talk about that in a minute. Although I feel like Sarah might have said something about that when you completed the square. Still talk about it. So just want to point out, we still need to find the x-intercepts. Now, before I do this, sometimes your parabola is not going to have an x-intercept. To kind of make sure that I don't waste time trying to find x-intercepts that don't exist, after you find the vertex and the y-intercept, I would encourage you to plot those points. Now, I'm not going to be super precise. Let me try and be somewhat precise. Sure, okay. So let's say right here is 3, negative 16. And over here is my y-intercept at 0, negative 7. So let me ask you guys, based on where these 2 points are, does my parabola open upwards or does it open downwards? Well, it can't, I guess you could think of it going downwards like that, but that would be wrong. It's got to be upwards. And the reason it'd be wrong to go downwards like this is because that's the vertex. The vertex has to be either the highest or the lowest point. Or you could do the easy thing and say, James, my coefficient is positive, right? If a is greater than 0, that means it opens upwards. That's another way of knowing which way it opens. So it definitely opens upwards. And since it opens upwards, we can see that we're going to have x-intercepts, right? Because it's going to have to cross the x-axis. Whoops. Also, my parabolas don't always look very good. So I've got a couple x-intercepts. There they are. So now let's find them. So I'm going to set this equation equal to 0. And I'm going to hope it factors, because factoring is nice. It does. This factors is x minus 7 times x plus 1 equal to 0. And then we see that we get x equal to 7 and x equal to negative 1. So there's your x-intercept at negative 1, 0. There's your other x-intercept at 7, 0. A couple things to be aware of here. There's like two things I want to say really. So first and foremost, maybe not first and foremost, but interestingly, the line that kind of cuts this parabola in half, called the axis of symmetry, is x equal to 3. I don't really care so much about that, but what I want you to see is that if there are x-intercepts, they are equally distant from the axis of symmetry. And that is always going to be true. The axis of symmetry is going to split it right down the middle. And so you can exactly see, well, if my x-intercepts are 7 and negative 1, then the middle of that's going to have to be 3. I feel like there's something else. Oh, yeah. And then you could also say that this function, this parabola, has a minimum value of y equal to negative 16 at x equal to 3. So sometimes we like to talk about the minimum or maximum value of a function. That's actually what a lot of, not a lot, but some of calculus is concerned with, is finding the maximum or minimum value of a function. So for a parabola, we can say, oh yeah, it's really easy to find the minimum or the maximum. You just find the vertex. So somebody did ask an excellent question, which is, where does that negative b over 2a come from? And there's a couple of different ways to find it or to justify it. Yeah, let me try it. I'm trying to think about which way is the preferred way to kind of show it. So here's one way you could do it. So let's say we have the very general equation, y equal to ax squared plus bx plus c. And I want to find the vertex. Well, in fact, let me do it by example. Actually, let me go back to that previous example, and then we'll come back to this. So if I did that previous example, y equal to x squared minus 6x minus 7, the negative b over 2a really comes from the completing the square. So if we actually did this one with completing the square, we're going to see a negative b over 2a. And let's remind you that our a is 1 and our b is negative 6. So to complete the square, check it out. Here's how we complete the square. You take your b and you divide it by 2. You're really dividing it by 2 times a, but here a is 1, so we don't miss it. So negative 6 over 2 squared, that's your negative b over 2a. And that's going to equal 9. So then when I rewrite this, I'm going to write it as y equal to x squared minus 6x plus 9 minus 9 minus 7. Right? I just added 9 and subtracted 9. I'm not sure if that's exactly the same way Sarah did it, but that's the way I usually do it. And then the reason I added that 9 was to complete the square. Then this part here is going to be x minus 3 quantity squared. And so this becomes y equal to x minus 3 squared minus 16. And when you write it this way, you exactly get the vertex. The vertex, well, we know this one opens upwards, so the vertex is the lowest y value. So what's the smallest y could be? Well, I've got something squared minus 16. Let me ask you y'all, what is the smallest x minus 3 squared can be? I know what you're saying. You guys are exactly answering the question. Just I asked it wrong. So you were saying if x is 3, it's going to be the smallest, which is totally right. And if x is 3, this whole part is going to be 0, which is the smallest it can be. And exactly, you're going to get 0 minus 16. So your vertex is exactly the same as it was before, right? Nothing changed. We just looked at it differently. The vertex is exactly the value of x that makes the whole thing as small as possible, and the corresponding value of 1. What I want to emphasize here is that this is exactly x minus b over 2a, sorry, x plus minus minus. Right, so when you're finding the x coordinate of the vertex, it's literally negative b over 2a, right? Because you end up, when you complete the square, you exactly get negative b over 2a. I feel like I'm missing a, I'm forgetting, I'm missing a sign somehow exactly. Oh, it's, yeah, okay, yeah, sure. Sorry, sorry, I feel like I just want to make sure I'm not screwing up the sign somehow. So my negative b over 2a should be negative 6 over 2 times 1, which is 3. So this should be not negative here. It is x minus b over 2a quantity squared. And so then you can see that, I feel like I'm, sorry, my brain is, no, yeah, that is actually what I meant to say. I apologize. Sorry, there we go. Right, exactly. So really what we're doing when we do this negative b over 2a thing is we're taking a shortcut, right? We are not doing the whole completing the square process. We're saying we know that if we were to complete the square, the x coordinate would be negative b over 2a. And the y coordinate would be whatever you got when you plugged in x equal to that x coordinate. So that's kind of what's going on there. Hopefully that kind of helps. Yeah, so the very, very short sum up to all that is you can graph a parabola by doing 3 things: finding the vertex, finding the y-intercept, finding the x-intercepts if there are any, and plotting them. So let's look at some more examples. What I will say, I don't think we need to go through it, but you could do the same sort of work here. It just looks a little bit messier when you complete the square, when a and b are just kind of constants that represent whatever. So if someone wants to see that in office hours, I'm happy to show it to them. But I really just want to show you guys kind of how to graph these things relatively easily and efficiently. So let's look at some more examples. Let's say we want to graph y equal to negative x squared plus 2x plus 3. Or if you prefer, f of x equal to negative x squared plus 2x plus 3. And I think it's a good idea to write down what a, b, specifically what a and b are. C, you probably don't need to write down. I'm going to write down that a is negative 1, b is positive 2. And yes, it is true that c is positive 3. And now I'm just going to start finding the things. And I'm always going to start with the vertex. So my x coordinate of the vertex is negative b over 2a, which is negative 2 over 2 times negative 1. And negative 2 divided by negative 2 is positive 1. Great. The y coordinate, I'm just substituting that 1 back into the equation. So I'm plugging in 1 for x, and I'm getting negative 1 squared plus 2 times 1 plus 3. Okay, be careful here. That negative 1 squared is square first, negative after. So it's 1 squared, which is 1, and then the negative of 1, which is negative 1. So this is negative 1 plus 2 plus 3, which is negative 1 plus 5, which is 4. So my vertex is the point 1, 4. Let's find the y-intercept. Well, the y-intercept is easy to see if it's written. Oh, how is it negative 1? So fair question. So this part here, right, there aren't any parentheses. My parabola is negative x squared plus 2x plus 3. And when you see a negative x squared, order of operations, right, some PEMDAS, if you like, PEMDAS, I don't know how you pronounce it, right, it says first you do any parentheses, okay, I don't have any. Then you do an exponent. So I'm going to do the squaring before I do the subtracting, because that negative sign in front is really like a subtraction sign. So I'm going to do the negative after I do the 1 squared. So it's really negative 1 squared plus 2 times 1 plus 3. That's why it's a negative 1 and not a positive 1. But I know it's kind of annoying, right? You're used to saying, oh, if it's a negative number squared, we get a positive, but it's not a negative number squared. It's a number squared and then negated afterwards, which is different. Y-intercept, no problem at all. It's going to be 0, 3. If we set x equal to 0, we get y equal to 0 plus 0 plus 3. And what I always think about, so there are 2 ways to see which way this, well, there's more than 2 really. There are 2 convenient ways to see which way this parabola opens. The easiest way is just to look at the A value. If A is positive, it opens upwards. If A is negative, it opens downwards. This one definitely opens downwards. You can also see here that the vertex can't be the lowest point because there's a point lower than it. So the vertex has to be the highest point, right? It's one or the other. The vertex is either the lowest point or the highest point. It has to be the highest point because there's a point below it. So when I start graphing this thing, I'm gonna be a little bit more precise than I usually am here. 1, 1, 2, 3, 4. There's my vertex at 1, 4. And here's my y-intercept at 0, 3, decidedly below it. So then I know it has to open downwards because that has to be the highest point. So it's going to go like this, like this. It also means I'm going to have x-intercepts. Let's go ahead and find the x-intercepts. So I've got negative x squared plus 2x plus 3 equal to 0. Yeah, I really don't like having a negative on my x squared. You can factor it this way. I am never good at factoring. Like I could try and probably screw it. Let's see. Maybe I can make it work. I think it's a negative x and an x. And I guess I want a 1 and a 3. So I want a plus 3 here and a plus 1 there. That one was probably the only time I've ever gotten that right. If I was doing this problem, what I would do is I would just multiply both sides by -1. So I would say this is equivalent to solving x squared minus 2x minus 3 equal to 0 and getting x minus 3 times x plus 1 equal to 0. In either case, you should get the same x-intercepts. This gives me x equal to 3 and x equal to -1, as does this. This gives me x equal to -1. This gives me x equal to positive 3, right? Because if negative x plus 3 equals 0, x has to be positive 3. And as expected, the x-intercepts are equally spaced out on either side of the axis of symmetry. Right, there's my axis of symmetry at x equal to 1, and my x-intercepts are 2 to the right and 2 to the left. There's our parabola. When drawing your parabola, let's say that word, when drawing your parabola, try to make the vertex curvy. It shouldn't be pointy. It should definitely curve, round out at the top, and then go back down. Or round out at the bottom and go back up. Yeah, that's all there is to say, really. This function has a maximum value of y equal to 4. It occurs at x equal to 1. I feel like there was another thing that I wanted to say about this one. Maybe not. Maybe we'll just do more examples. Let's do more examples. Okay. So it gets to be a little repetitive. That's all right. Half of math is practicing stuff. Lights. Light's killing me. All right. 1 second. Drink of water. A little thirsty. Okay. So let's try graphing this one. Y equal to x squared minus 5x minus 6. So same deal. We're going to find all the things. We know it opens upwards. Let's find the vertex. The x coordinate is going to be negative 5 over 2 times 1. Well, this is going to be a little less nice because our vertex is going to be not a whole number. It's going to be 5 halves. You could use decimals if you want. I prefer fractions. The y coordinate of the vertex is going to be 5 halves squared minus 5 times 5 halves minus 6. All right, so 5 halves squared is 25 over 4. And 5 over 1 times 5 over 2 is 25 over 2. Pen. So we need a common denominator of 4. So this is 25 over 4. I'm going to multiply this by 2 over 2 to get 50 over 4. Multiply 6 over 1 by 4 over 4 to get 24 over 4. So 25 minus 50 is negative 25, and negative 25 minus 24 is negative 49 over 4. So my vertex here is 5 halves, comma, negative 49 fourths. And what I would see here is, well, 5 halves is right between 2 and 3. And negative 49 fourths, well, 49 divided by 4 is like 12 and a little bit more. It's 12 and a quarter. So I would kind of mentally know, okay, that's close to 12. Negative 12, I should say. Let's find the other things. Y-intercept, no big deal. It's 0, negative 6. Right? I'm not even thinking about plugging it in really. Well, I mean, I am. 0 minus 0 minus 6. There we go. Once again, if I'm graphing this thing, I don't want to start finding x-intercepts until I've determined that there actually aren't x-intercepts. So I'm going to try and plot some of this just to make sure I know what's going on. Here's my vertex at 5 halves, which is halfway between 2 and 3, and way down here. See how I'm not drawing a bunch of marks? I mean, I drew a few, right? That's 2, that's 3. Here's my point, 5 halves, comma, negative 49 fourths. And I'm writing my vertex below it because I know it opens upwards. And it opens upwards because my coefficient here is positive, or because my y-intercept is definitely above. Okay, so we do get x-intercepts. So let's set this thing equal to 0 and find them. X squared minus 5x minus 6 equals 0. I think that factors. So this is where you always have to be careful, right? It's really easy to factor this one wrong. It's not going to be 3 and 2. It's going to be negative 6 and positive 1. So it's going to factor as x minus 6 times x plus 1. So I end up getting x equal to 6 and x equal to negative 1. So there's one of them. There's another one. And you'll notice they're still both equidistant from what would be your axis of symmetry, right? This one is 1, 2, 3 and a half to the right. And this one is 1, 2, 3 and a half to the left. And then just try your best to graph it. Well, it turned out pretty good. If anyone asks, we should be able to say that the axis of symmetry, it's always just x equal to whatever the x coordinate of the vertex is. So very generally, it's x equal to v sub x. in this particular problem, my axis of symmetry would be x equal to 5 halves. And then there was something else I wanted to mention. Oh yeah. In this case, do we have a maximum or a minimum? We definitely have a minimum. So the minimum has a u in it, value is -49/4. And just to be very, very explicit, it does not have a maximum, right? A parabola can either have a maximum or a minimum, but not both. There is no maximum value as this thing gets larger and larger and larger and larger and larger without bound. Sorry, my forearm kind of started not feeling great. So they do get, well, actually this next one's not more complicated, but this next one illustrates an important point. So let's say we wanted to graph the parabola f of x equal to x squared plus 4x plus 5. And we start going through the usual motions. Our x coordinate of our vertex is -b over 2a, which is going to be -4 over 2 times 1, which is -2. And our y coordinate is going to be f of -2. Actually, the y coordinate of the vertex. It's going to be f of -2, which is, now watch out here, right? Before, just kind of go back to a question someone asked. That before, when I had -x squared and I plugged in a positive number, I had the negative of a positive number squared, which was negative overall, because I squared it first and then did the negative after. But here, I'm plugging in -2 and then squaring it, so it's going to be -2 quantity squared plus 4 times -2 plus 5, which is going to be, well, a negative number squared is a negative number times itself. That's going to be +4. It's -2 times -2. -8 plus 5. 4 minus 8 is -4. -4 plus 5 is +1. So our vertex here is the point -2, +1. And our y-intercept is going to be the point x is 0. And if x is 0, I'm going to get 0 plus 0 plus 5 for the y value. And if I start graphing this, I do like being a little more precise sometimes when I graph these parabolas. So here's my vertex at -2, 1. And here's my y-intercept at 0, 5. And I think we can all see, well, this parabola definitely opens upwards. And so I'm not going to get any x-intercepts. When that happens, I generally find I don't have enough points to really make it look nice. So what I typically do, if I only have a vertex and a y-intercept, is I like to reflect the y-intercept across the axis of rotation. So I know that there's symmetry about this point. If I go 2 to the right, I'm up to a height of 5. The same thing should be true if I go 2 to the left. If I go 2 to the left, I should be up at the same height. So if 0, 5 is my y-intercept and -2, 1 is my vertex, then if I go 2 more to the left, I should have a point that has the same y value, -4, 5. Why will you get, that's an excellent question. Why will I get no x-intercept? So there's a multitude of ways to answer that. One way to answer it is just by looking, right? If the vertex has to be the highest or the lowest point, and here it's definitely the lowest point because there is a y-intercept above it, we just can't, right? Graphically, there is no way for the vertex to be below the y-intercept like that and still get x-intercepts. But we can also see it using our algebra skills. Let's try and find them. How do we find the x-intercept always? We set y equal to 0. So what I want to mention before I do this is the point of looking at it graphically is to avoid doing the work I'm about to do. Because the work I'm about to do is going to show us that there aren't any x-intercepts, but it's also going to feel like kind of a waste of time. That's okay. But I just want to point out, you can totally say there's no x-intercepts just by looking at the graph. But you can also try and find them. So I'm going to set x squared plus 4x plus 5 equal to 0. And while it looks like it might factor, it actually doesn't. There's no way to multiply to positive 5 and add up to positive 4. 1 and 5 are the only real ways to multiply to 5, and that doesn't add up to 4. And you might be thinking, oh, like negative 1 and 5, but it can't be negative 1 and 5, right? Because that's a positive 5 you have to multiply to, not a negative 5. So when we can't factor, we fall back on the quadratic formula. So we're going to get x equal to negative b plus or minus the square root of b squared, which is 4 squared, minus 4 times a times c, which is 4 times 1 times 5, all over 2 times 1, but that's going to be imaginary. I mean, negative 4 plus or minus the square root of 16 minus 20 is negative 4. And the problem is that's not real. We can't graph imaginary numbers when we're on the XY coordinate system. Right? There is a way to graph imaginary things using a totally different system, but that's not what we're doing here. So once you get to here, like, oh, there's no real solutions. So there's nothing to graph. So you can certainly do this to show that there aren't any x-intercepts, but all you have to do is recognize that your vertex is above the x-axis and it opens upwards. Or your vertex could be below the x-axis, like at the point, I don't know, 3, -2, and open downwards. That would also be an example of something. Like this would be, I don't know, negative x minus 3 squared minus 2. That graph, which you could then multiply out, which would be negative x squared plus 6x minus 11. That graph would have no y-intercepts for the same sort of reason. Sorry, no x-intercepts. Apologies, you always get y-intercepts. Good question. I like that question. I'm happy to talk about it. So then we just look at some less fun examples, some numerically more challenging numbers, examples like the following. Let's graph f of x equal to 2x squared minus 5x minus 3. Same idea. We're still going to find the same 3 things. X coordinate of the vertex. So it's going to be negative b over 2a, which is negative 5 over 2 times 2, which is 5/4. Things are a little dicier when there's fractions. The y coordinate, again, whenever you're finding the y coordinate of the vertex, you are just plugging back in the x coordinate to the function. So it's going to be 2 times 5/4 squared minus 5 times 5/4 minus 3, which is going to be, let's see, 2 times 25 over 16. 5 times 5/4 is 25/4, right? Because it's really 5 over 1 minus 3. So let's see, the 2 over 1 here, I can cancel a 2 and a 2 and get an 8 in the denominator. So that's going to be 25 over 8. I can multiply 25 over 4 by 2 over 2 to get 50 over 8. I can multiply 3 by 8 over 8 to get 24 over 8. This ends up being 25. This is actually the same subtraction we did before, just with a different denominator. 25 minus 50 is negative 25, and negative 25 minus 24 is negative 49. Now we got negative 49 over 8, which is close to like negative 6. So our vertex is the point 5/4, which is a little bit bigger than 1, and negative 49/8, which is slightly more negative than negative 6. And then I guess I could find the y-intercept. Y-intercept, I really like, you can just graph it. I don't even think you need to show me that you found it because it's almost always just right there. I should mention, this is something to be super careful about. If you did have an example like this, where it was written in the completed square form, The y-intercept is not -2 here. Right? To find the y-intercept, you have to plug in x equal to 0. And if you did that, you would get y equal to -0 minus 3 squared minus 2. 0 minus 3 is -3. -3 squared is 9. So you get a -9 minus 2, which is -11. So just be careful. If you've got the completed square form, when you plug in 0, it's a little bit more work to find the y-intercept. Whereas if you got the usual standard form, when you plug in 0 to find the y-intercept, it's super easy. The -50/8 came from multiplying 25/4 by 2/2. I should say -25/4 by 2/2. And the 24/8 came from multiplying 3/1 by 8/8. All right, so let's get to graphing this thing. I know we haven't found the x-intercept yet. That's okay. So my y-intercept is 0, -3, which I usually don't graph first, but I happen to just because I looked at it first. And my vertex is a little more than 1, a little more negative than -6. So, okay. -4, -5, -6, -7. So it's like maybe like there-ish. Definitely going to have x-intercepts, right? This opens upwards. It's going to hit the x-axis. So let's set that equal to 0. And at this point, it's kind of up to you which way you want to solve it. You could try factoring, or you could try using the quadratic formula. Quadratic formula is always going to give you a result. Factoring might not always, although most of the time it will. This does factor. This factors as 2x plus 1 times x minus 3. Now, I know I'm not showing all the work for the factoring there, and that's because for this one, it was easy for me to guess and check. I know there's only one way to multiply to 2x squared. You have to have a 2x and an x. And there's only a couple ways to multiply to -3. And 1 and -3 in this particular formation work. If I multiply it out, I get 2x squared. I get -6x plus x, which adds up to -5x. And then I get a 1 times -3, which is -3. So that means my x-intercepts are going to be x equal to -1/2 and x equal to +3. Oops, that's not where that goes. That's -1. Here's -1/2. And although it's not quite as easy to kind of numerically see, these are both the same distance from our axis of symmetry. This is 1 3/4 to the right. This is 1 3/4 to the left. Oh boy. Okay, not my best. Oh, it turned out okay. I should mention that if you are using kind of the standard, oh my gosh, words, the standard scaling where the x and the y-axis have the same scale, if your coefficient out here is larger, right, like if it's 2 instead of 1, your parabola should look stretched out vertically, right? It's going to be steeper because in fact, it's exactly like when we were doing trig graphing and we multiplied by a number out in front and gave it a bigger amplitude and stretched it out vertically. The same thing happens when you multiply the x squared term by something that's bigger than 1 or different than 1. It's going to stretch it out vertically. Let's see. I think we've got time. We've got time for one more example. I want to do, let's see. I want to see if, I know I don't. Okay. No, we got 2 left. I should.
Plotted the vertex.
Yeah.
Like 5/4. Like I feel like I get confused when I see a fraction and like plotting. How do you go about that?
Like how they go about plotting that point?
Yeah. Just because hear me.
So what I'm thinking here is, I mean, you could literally change it to a decimal, right? 5/4, if you plug it into a calculator, is going to be 1.25. -49/8 is a little less nice. -49/8 is going to be -6.0. 1/8 is -6.125. Sorry.
Okay, thank you.
That's one way. That's kind of the fastest way to do it. But what I was really doing is I was kind of saying 5 divided by 4 is 1 and a little more. And 49 divided by 8 is 6, and there's a remainder. So that's how I kind of know it's more than 1 and more than 6 when I'm graphing it. Yeah. Just trying to think there. So I want to mention, I don't believe any of the homework problems have x-intercepts that are irrational, but I want to show you an example just in case one like that shows up. So there are 2 more examples in the notes that in the old notes that if you want more examples, they both have fractional examples. There's a 3x squared minus 10x plus 3 that you could look at on your own, which would be a good example to work through. There's also a negative 2x squared plus 6x minus 5. And this one doesn't have any x-intercepts. But what I want to show you is an example where we have x-intercepts, but they're not nice. Like they're not even rational. They're irrational. So I'm going to make something up because I didn't have one prepared. Let's try graphing f of x equal to, let me think for just a minute here. I know. I want my b squared. Sure. Let's do something really nice and easy like x squared plus 4x. Yeah, let's do plus 4x. I'm sorry, let me be real careful before I blow it here. Sorry. Sure, let's do that. Let's graph this thing. So first, the vertex. The vertex is going to be negative 4 over 2 times 1, which is negative 6. Sorry, I misspoke. I really should say the x coordinate of the vertex, right? That's not the whole vertex. That's just the x coordinate. The y coordinate is going to be f of the x coordinate, which is f of negative 2, which is negative 2 quantity squared plus 4 times negative 2 plus 2, which is going to be positive 4 minus 8 plus 2, which is negative 4 plus 2, which is negative 2. So my vertex here is the point negative 2, negative 2. How exciting. They're the same. Everything's 2 or negative 2. The y-intercept is going to be x is 0 and y is 0 plus 0 plus 2. Okay, so now I'm going to do my usual thing where I start graphing it before I think about the x-intercepts. So my y-intercept is 0, 2, and my vertex is negative 2, negative 2. So I can definitely see that, oh yeah, I'm going to have x-intercepts because it opens upwards, or because my vertex is below the x-axis and it opens upwards. So now I want to find the x-intercepts. But the problem here is that x squared plus 4x plus 2 equal to 0. X squared plus 4x plus 2 doesn't factor. So I have to use the quadratic formula instead. So my x-intercepts are going to be x equal to negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 2 all over 2 times 1. And then we're just going to simplify this as much as we can. So it's going to be negative 4 plus or minus, let's see, that's 16, that's 8. So 16 minus 8 is 8. So the square root of 8 all over 2. The square root of 8 we can simplify, right? The square root of 8 is the square root of 4 times 2, and the square root of 4 is 2. This becomes negative 4 plus or minus 2 root 2 all over 2. And then negative 4 divided by 2 is negative 2, and 2 root 2 divided by 2 is just root 2. A couple nice things to observe right here. One, we can see really from the quadratic formula that our x-intercepts are going to be equally spaced out from the x coordinate of the vertex, right? The x coordinate of the vertex is negative 2, and we're doing negative 2 plus root 2 and negative 2 minus root 2. So we're just going the same amount from to the left and to the right. Now, negative 2 plus root 2, I don't want to know what that is. I don't really care. I know that root 2 is somewhere between 1 and 2. It's about 1.4. So all I'm going to do is I'm going to say, I'm going to start here and I'm going to go about 1.4 to the right. and about 1.4 to the left. Or really, as I would say, 1 and a little bit more. Okay, the last thing I want to say about this, because it is kind of cool. To answer the question about the negative b over 2a again, you can kind of see it from the quadratic formula, right? If the x-intercepts, if they exist, are negative b plus or minus the square root of b squared minus 4ac all over 2a. If you break that up into two fractions, it's negative b over 2a. Oh, negative b over 2a. Plus or minus the square root of b squared minus 4ac all over 2a. So this is the negative b over 2a axis of symmetry. And then to find the x-intercepts, you're just going the same amount to the right and the same amount to the left. That's kind of another way to really kind of convince yourself that, oh yeah, the negative b over 2a really, really is the x coordinate of the vertex always. All right, as usual, I've talked until 2:22 because